Well, thank you to our guests from Merck for coming to hear this. Other students as well, glad you could join us. I'm really just going to turn it over to the students to introduce themselves and their work.
I'm John Pollock.
I'm Andrew Carr.
I'm David Durski.
I'm Charles P.
I'm Rocco Fatuva.
I'm Nick Zambelli.
I'm Jordan Luciano.
I'm Justin Medelia.
I'm Devin Harris. We're going to present our project Clashboard to you guys today. I just want to go over a little bit what we're going to talk about, just keep track of where we're at during the presentation. First, we're going to start off with a little bit of a background of the project and where it originated from. Secondly, we're going to have a demo right before the project. We all held hands and prayed to the demo gods, so let's cross our fingers and hope that goes well. Then we're going to dive into the technologies, the back-end technologies of the platform, and go over that a little bit. And then we're going to wrap it up with the lessons that we learned along the way and some challenges that we faced. So Merck approached us with an idea that they needed something that could help them understand and kind of gain insight on what the clinical trials are doing in the pharma space. One of the issues that they faced with this is that Merck itself doesn't have one-stop place to look at clinical trials and in a 10,000-foot view to kind of understand and analyze. There's no one easy place for them to understand it, let alone their information or sponsors. Their competitors. So the problem that we had to solve was trying to congregate this data and find a way to do that. Since there was no one-stop place for just Merck to do this, it was kind of a difficult problem space to find an answer to originally, but luckily we found a database Michael actually brought to our attention early on that is run by the CTTI, the Clinical Trials Transformation Initiative. It's called the AACT database, the Aggregate Analysis of Clinical Trials. This holds not all, but most clinical trials data that's known, both from Merck and from many other companies. This database contains non-personal information that's important to know of over 300,000 unique different trials. So there's a lot of information in this database that we can look at, and then there's information such as study type, phase that the clinical trial, that unique clinical trial is in. Other things such as, sorry, I'm blanking on what? Oh, enrollment type, yes, I wasn't going to mention that, but enrollment type and a few other column spaces. And sponsors' names, so the name of the sponsor that's actually running that clinical trial. And with that information, we have, blanking really hard now. So what our job was to do is actually take that information and make it into a usable form for Merck.
So, with all this information, it can be useful to a company. It can help you save money. You can see how your competitors are doing. You can also see how you're doing as well. Especially for a pharmaceutical company, being able to view all of these trials and being able to see how many there are, and this can help you determine what research area you want to invest in. Also, when you're running a trial, you can save money by using a device, and these devices can be used to help gather patient vitals instead of having them come in every week or so to go to the doctors to get an examination. But how do you know what trials to use the device in? Well, our dashboard will be able to, these are all the devices, our dashboard will be able to show you what therapeutic areas there are, and within each therapeutic area, you'll be able to see how many studies rely on a device and how effective that device is. You can also see if the compounds used in a specific area can be used in other areas as well. This can help you decide whether a device will be beneficial in an area or if you'd like to invest in that area. Another feature we have is the ability to see how your competitors are doing. You can be able to see what areas they are targeting or what drugs they are using, as well as see the progress they are making in their research. This can help Merck determine where to best allocate their resources to compete with their competitors. And we also have the ability to see all of the Merck trials by filtering the sponsors by Merck. We have another feature is that you can view a study's phase, overall status, and enrollment type, like Devin said, But with this data, you can also view it in a pie chart or a bar chart, and you can download this data and use it to enhance the presentation. So now that we have an understanding of the capability of our system, let's take a look at a case where our system can be used.
So, this demo, imagine that I'm a Merck employee and I'm tasked with trying to find out what trials were terminated in early phases. So here you can see that on this we are currently at categories by enrollment type. And for this we would want to see trials that were actually enrolled. So we can click on the pie chart, it'll rerun, and it will give us an update, and now you can see we're filtered by actual enrollment. And then we want to go to phase. And now here we can see, here are all the phases that are had actual patients enrolled in the trial. And since we want early trials, so say phase 1, we can filter on phase 1, and now we can go to overall status. So here we can see all of the trials that were actually enrolled and in phase 1. And now, since we wanted to look at which trials were terminated in early phases, we can sort terminate. And now we have a pie chart that's showing how many trials had actually enrolled patients were in phase 1 and got terminated. We can see that it is only down to 1,692 trials out of the starting entries of a little over 300,000. So, but let's say we don't want phase 1. Let's say we just want to know which phase had the most terminated trials with people actually enrolled. Now we can delete the phase, and then we can see it here, or we can go to a bar graph, and we can see that phase 2 has the most actually enrolled patients in a trial that the trial was terminated. So now let's take a look at how our system goes about reading all the data and using the dashboard.
So as we talk about our system, we can start by looking at a very abstract, very high-level view of the architecture of our system. This architecture describes the database and where we get our data from, the API, which is in the middle doing all the translation and the interpretation of the data, and ultimately the GUI, what you just saw in the demo, of how you, the user, can interact with the system. This architecture seems to be very straightforward, which it is. There's not a lot of complex moving objects and there's not a lot of complexity to it, but that didn't mean that we didn't have to focus and carefully design the system. This API is responsible and the key in order to making our system work. By having this API carefully crafted, we were then able to keep all of the components of our system loosely coupled. This means that if we ever need to change the type of database or the database that we're getting data from, we can change that, and yet all of the interaction that happens still can follow the same format of our API, and we can still keep that intact. If we ever have to change the GUI to it, we're more than free to do so because our API has created those definitions for it. So as we go through, knowing that our architecture keeps all these components loosely coupled, the information that the GUI has that the user interacts with is not necessarily and doesn't need to be the same information that you would use to actually fetch the data directly. So as we go through, before we even talk about how the data flows through, we need to first establish what exactly our data looks like and the data that we're handling.
So, database is comprised of many tables, as we can see. Has a very complex schema. There's obviously a lot going on here, but don't worry, the purpose is not to intimidate you. In this graphic, you may be able to see at there we go. Maybe able to see at the bottom here. There are some lines connecting to the bottom. Those are tables that we cut off. All of those tables cut off relate to the clinical results of the trial, but all of these tables here have information that we're most interested in. For example, this table up here pertains to the different design aspects of a trial. Over here we have the countries table, where the trial took place, and the sponsors table that has the different sponsors of the trial. Our main concern lies with the information stored in this centralized table here, the studies table. This table gives a wide assortment of information. Each row of this table contains information about a single clinical trial. It contains information such as, over here, it says study type. If I could find it among the forest of variables here. There we go, someone found it. The study type, we have the enrollment type, also the overall status and phase. We focused on this table because it has the most information available to us in a single table, allowing for easier navigation and more data collection with less navigation of the database itself. The variables on the left side here, there are ones that we didn't use because they would have taken more time, and they're ones that we did not choose to use. However, with our design, if we wish to implement these variables in the future, the connection of our API and GUI would allow for that because of our loosely coupled nature. The variables that we did choose, the ones that I've mentioned on the right side, are the variables that we saw used in the demo. So the data pertaining to those variables is very simple. Here are some of the tables that represent the different values that you can get for each of these variables. With the roughly 300,000 entries in this data, and each of those entries having values for each of the variables, that still leaves a lot of data to sift through. However, if we choose these, we chose these variables because they could be easily categorized with the right SQL statement. As I mentioned, these variables that we did choose have great variance in themselves, which we will look at now.
So as Justin mentioned, we have variables that are easily defined and quantifiable, and just as well as that, we have a lot of variables in the database structure that are not as easily defined and don't have as many or as easily to quantify options. One of the things that we wanted to look at was the sponsors name table. The sponsors table names that are in that, the names column of the sponsors table. In that, it's just it's simply just the name of the company that sponsors these clinical trial. And one of the things that we noticed upon just an initial look is that there's a lot of variance in the names that appear in there. So we took one example, we just wanted to take a use case, and we looked at Merck. So we looked at anything in the names column in the sponsors table that contained the name Merck or the abbreviation MSD, two very commonly known ways to represent the company name Merck. We found two major players in that there were Merck Sharp and Domport, and then Merck KGaA Darmstadt, Germany. And then there was about 82 other things in there that we saw that contain Merck or MSD. And you can see that they're all represented here. Not all, they're in the same chunk here, but you can see the breadth of the data. So we had to do something about that to make the data more understandable and easier for us to quantify what we're looking at to the API. So what we did was we actually, we have a local copy of the database, which we'll talk about a little bit more later, but in our local copy of the database, this enables us to do a few things. When we make that local copy, we run a pre-processing step that actually can control a little bit what's in the database and makes it easier for us to look at. I kind of tried to blow up this picture for you a little bit, did my best job with it. But you can see the existing sponsors table in the initial hosted sponsors in the database contains five entries, but the two that we really are concerned with are NCTID and name. With the, like I said, the name is the varying column. So what we needed to do is we needed to run a match on name and try and regulate it to something that we can define what we want to expect in our API. So one of the implementations that we did was in the sponsors column for Merck. Whenever we saw the name Merck appear in that string, we made a new table in our local copy of the database called curated sponsors, and that contained the NCTID corresponding to that clinical trial or that study, and then the curated sponsor name, which would have just been Merck. So if we see, like on this slide, if we see Mark Sorono Middle East, we just changed that to Merck for the curated sponsors column, and then we know that for anytime we see that NCT ID, that sponsor is in fact Merck. We're going to talk about now a little bit how the pre-processing step is initiated and a little bit of the operations that go with that.
As you're doing the handoff, quick question, do you want questions at the end? Or do you want questions now?
Well, let's do questions at the end. We'll get through this first, and then we'll answer it.
Sorry, so hopefully I can throw that on.
So, as Devin mentioned earlier in the introduction, the data is gotten from the clinicaltrials.gov website. The data has been pulled on this or updated on this website since 2000, with most of the data coming after 2005. Today, the data is updated almost every day. This data was pulled straight from the database available online, and it's not been manipulated by us in any way prior to when we actually store it. In order to download the data, we created a simple script that accesses the AACT website and finds the most recent day that a new archive of the data was added. The database is then extracted from that archive and imported into a PostgreSQL database. Once the data is properly stored, we were able to apply transformations to it, such as the new curated sponsors table that Devin mentioned. So we've just spent a lot of time looking at the data through a magnifying glass here, going very deep level. So we're going to pull back for a second and take a broader look at something more generalized in the form of our API.
So when we look at our API and how it was carefully crafted, one of the things that we kept in mind was being able to keep the complexities of the database side and the queries necessary away from the side of the GUI and the user. These are examples of the endpoints that the GUI uses in order to call the API and to add data to our system or to refine the search necessary. So the GUI has the power to apply filters, has the power to remove filters, as you saw in our demo, as well as set the group by using the drop-down menu. And never once has to ever think about the idea that it could be a SQL database or that there could be queries created, and it really doesn't need to. It's so loosely coupled that if we ever need to change that database out, this definition still works for our GUI. And as long as we change the GUI out, as long as it's able to call our functions correctly, then we can use the different GUIs that we want to. So with these definitions, it's very straightforward for the GUI to use it, and it's very visible as to what's happening, and these are very literal names, as to how the views and how the data is changing on a user side that's far disconnected from what's actually happening. So once this API is defined, and once we have all of these different functions that are used in order to set the different views of the data, in order to filter the data, and to group the data, now we can start talking about the flow of the data and how that actually works through our system. So the API isn't called from the database side. The database will sit there, and our communication and our queries with the database are acted and started through the GUI. So the GUI, once a user will click the drop-down and change their drop-down, it can call this set group by, and we can change it to overall status. The API is then responsible for translating that over and creating the group by line that's within our SQL statement. As a filter is applied, the GUI will again call and say, I want to apply this filter, and say the filter I want to apply is Roman type, and what I really want to see are the clinical trials that are actually enrolled. And then as we go through, if we apply more filters, it's a matter of the GUI calling that same function with just this is the type that I want to call and the group that I want to call, so phase. And what I want to be specific with is I want to see everything in phase 1. The API is then responsible for then translating that over to knowing that it has to modify the SQL statement and has to add more to it. The beauty of this is that the logic happens on this side as we get towards the database side. Nothing makes this more complex as long as the GUI sticks to the standards and sticks to the definition. As more filters are applied, the GUI is responsible for calling that same function and adding more. The logic of which tables we use and how we use them and whatnot is added and improved upon from the database side of it when we actually construct the queries. So once the GUI has called these functions and we have a query constructed, now we can actually interact with the database and collect that data. And so once we have that data, now we can take a look at how that comes back up through our system towards the GUI.
All right, so when the data is on its way back, we summarize it into a pandas table, pretty much just like this. And as it flows through our API, what our API does is it turns it into a more simple format for the GUI to work with. So as you can see here, completed, terminated, active, but not recruiting are all exactly in the same order, and they're just in a simple list of strings that the GUI can work with and use to label their pie chart. On this side, we have the counts of each one, and they're in the proper, again, the order stays the same, and it's just a simple list of integers that the GUI can work with. This makes it a lot more straightforward of an interaction for the GUI, and it removes all the SQL logic. So now looking at this API, it actually is broken down into two distinct parts. One of them is a database class. This is where all the SQL query logic lies. This is where we do all the connections to the database and we handle that type of stuff. This is where the summarization of the data comes into play. This is where we make the tables. The link that you see there, that's our interface. That's what the GUI sees. That's what the GUI is interacting with at all times. With this design, we're able to add tables easily as we move on. We know exactly where that's going to happen. We know that that's going to happen in the database class itself. As we add more tables and more complexities, nothing actually happens on the GUI side. As far as the GUI is concerned, we're looking at the same exact code, we're looking at the same exact endpoints. There's nothing new. That's all good. As far as the interface is concerned, all that we add is the new value for the dropdown. So we saw the curated sponsors. We could easily just add that into the list, and now the GUI knows it's an option because the interface told it so. The key advantage to this is, like I said, the simplicity on the GUI side, and we know exactly where the new changes are going to have to go in to add all of those tables that you saw. And this interface, this API, is very vital to our system for a couple of reasons. The first of those is that it serves as a layer of communication. It translates the user inputs taken from the GUI, basically human readable type things that you'd expect to see as a human, and turns them into the variable components that the database needs for SQL queries. This makes it a lot easier. Like Charlie said, we've separated the SQL completely out of the GUI side, and you can plug in any visual representation that you like. That's another advantage to our system because it's so versatile. We can pull the GUI away, we can put a new one in place. On the database end, we can pull that away if we got sick of the AACT database for whatever reason. Maybe we wanted to write our own, maybe we wanted to use CSV files. All we would have to do is tell the database class how to interact with that, and the system is up to date. The system can keep running. And then finally, the biggest advantage to our API is the fact that it emphasizes thorough and thoughtful design. We emphasize that a lot in our course, and it was a big selling point for us to learn. So the way it emphasizes that is just that separation that we've been emphasizing, that we've been talking about this whole time. That's pretty much the biggest aspect of it. So now that we kind of have an idea of how the API works, how the data is flowing through, now we can see how our dashboard visualizes that data. So here's the diagram of how our dashboard works and interacts with the API. Our dashboard utilizes the model view control design pattern. The first part, the model, which is the API in our system, does all the data management separate from the GUI. It is the only part of the system that has access to the data and simply sends and receives data when prompted to. The second part is the model, or the view, that is the GUI in our system. This is the part that the user has access to, the only part the user has access to, and displays the data and allows the user to interact with the data. So it displays data in the form of a bar or pie chart, and allows the user to interact with the data by creating or removing a filter. And the third part, the controller, acts as a bridge between the model and the view. It is the main way that the model and the view communicate to each other by sending and receiving data to and from each other. In our system, we have these two methods, update plot and onClick. The first method, update plot, takes in the data from the API and repopulates the table with the new data and sends it to the GUI to be displayed. And the second method, the onClick method, takes in user interaction, either when creating a filter or deleting a filter, and sends that info to the API to requery, to send to the database to requery and use search. So at the beginning of the semester, we originally intended to use Shiny R and Shiny Apps to display and host our application. Here you can see the last working model we had. About halfway through the semester, we decided to switch to Dash by Plotly. The main reason for the switch was to keep our code base on the same language, in this case Python. As you can see, the original Shiny application looks very similar to this new one, only with a few minor features that we added to the new one. And overall, we are pretty satisfied with how the interface turned out, but we will be the first to admit it's pretty rough around the edges and not exactly something
we would expect the user to want to use for an extended period of time. The main group of us who worked on this interface had very little to no experience working with graphics before in an application. Dash allows you to implement CSS, JavaScript, and HTML in their application. We just didn't really have the experience to do that. Thankfully, due to the way we implemented our application, as well as the benefits of the model view control pattern, it is very easy for a new team to take over this project and implement their own GUI without having to worry about messing up or creating errors in the error parts of the system. This was something that was heavily stressed throughout the semester, and is one of the biggest features of our project. So if a team took over this project and wanted to create a GUI that fit more to their needs, they could easily do that without having to worry about breaking the database or the API.
So, throughout the semester, we used GitHub to keep track of our work. We had one central repository, and each of us created our own developer fork of that repository, which we could do our own work in. Within our individual developer forks, we also each had our own branches, which prevent us from accidentally adding work-in-progress code to our forks. Whenever we made sufficient changes in our branch, we would commit those changes to our fork. These changes were then processed into a pull request, which, if it passed the requirements, could then be merged into the master branch. However, because there were many developers working on this project, there were frequently different branches being worked on simultaneously. For example, let's assume that the red boxes and the blue boxes are two different branches being worked on by different developers. One of them would inevitably finish before the other. For example, in this case, the blue branch. They would then merge their code back into the master branch, at which point the red developer would pull the changes to their branch and continue on with their work until they inevitably push back to the master branch. This can be seen in one of the pull requests that we made over here. This pull request contains several commits and peer review comments made by various members of our team to make sure that the code was up to our desired standards. Once these standards were met, the code was then merged into the master branch. As I just mentioned, we had certain standards that we set which had to be fulfilled before we merged any new code into our repository. In addition to our own human checks for these standards, we also set up automated checks for them. First, we set up a Travis CI server in the master branch of our GitHub repository. This server prevented any code from being pushed from our forks to the master branch unless it passed the checks that we set. These checks were that there were no code conflicts, that the code fit into our PEP 8 coding standard, and that 90% or more of the code was covered by tests. If the code passed all the requirements, then the Travis CI server would give the OK, and the developers would get involved again and would have the opportunity to merge the code into the master branch. This check process also gave us ample opportunity to peer review the code, as shown on the previous slide in the pull request. On the other hand, if the code failed any of the checks, the developers would then be notified so that they could fix whatever was causing the code to fail the checks. Throughout our project, we also used Scrum meetings and a Jira board to keep track of our progress. The Scrum meetings were daily meetings where we could briefly state what we had done, what we intended to do next, and what roadblocks we might have run into along the way. Meanwhile, the Jira board was an online progress tracker, shown here, which we could use to create cards which represented any tasks which need to be done, and we could also use it to indicate how far along each of those individual tasks were. Each of these tools made it much easier to maintain an idea of how far along the project was compared to what we had planned out. These are some of the very beneficial technologies that we used, and we also learned about several other technologies and explored other ideas throughout this project.
So now that we finished the project, we spent some time reflecting on some of the things that we learned, and one of the the best things that we learned was starting with a good design. Because we took some time to start with a good design in the beginning, while we had to change some things throughout the semester, it made it a lot easier because we had the foundation that when we had to make changes, we didn't really have to restart the project since we already had a good basic base of the design. And this kind of goes into our second learning, which was always be ready for change. We started the project and we thought, this is definitely the way that we're going to go. And then once we kind of changed a couple times, we knew that we always had to be ready for different things to come up, maybe roadblocks that we had to change. Or just like they said, we changed the GUI design. We changed some of the things that we did in the interface as well. This kind of goes into being willing to try new things. These are all the technologies that we've used throughout the semester, and a lot of these people have never used before. Just like John said, a lot of the people that had done the GUI had never used Plotly or RStudio, and I've never used Python or Pandas. So we always had to be ready to try new things and be willing to interact with new technologies. And because people were willing to do this, our project was really successful. And as Andrew mentioned, collaboration was a huge thing for us. Working with GitHub, some of us have done in the past, but on a much smaller scale, working with 9 people, we had to be able to communicate with each other about pull requests, pushing new things to the project. And working on the Jira board was really important to keep track of what other people were doing. Kind of halfway through the semester, we had gotten away from using the Jira board as much, and Coleman was like, we gotta get back to the Jira board, gotta make sure that we know what we're doing, because some days we come into class and we're like, we have no idea what other people are doing, and we need to really be more on top of this. And our last biggest takeaway was understanding project scope. We came into the semester obviously talking with Merck about what they wanted to get out of the project, and of course all of us are really excited about doing different things for the project. And as we got throughout the semester, we realized some of the things that we had originally hoped we would accomplish, we haven't gotten done throughout the semester. But because we understand what we wanted to get done, we see some of the future improvements that we can do for the project. And one of them was, as Devin has mentioned, the sponsors functionality. We've gotten the Merck one to work because we found the 84 different combinations of your name and been able to do that, but we would love to do that with all the sponsors, so it's easier for you guys to see progress with every sponsor, what kind of studies that they're doing and that kind of thing. And another improvement that we wanted to do was incorporating all of the data. So while we were using the studies table, because that has most of the information, we want to be able to incorporate all of the tables so then you can access all the information that you want. With this comes some challenges that we think we're going to face, but because of the design that we've used, we think might be a little simpler. One of them is the complication of joining a lot of tables. Once we start trying to figure out things maybe with the sponsors, the studies, locations, that kind of things, we're going to be doing 3 or 4 joins of different tables. And this comes into play when we think about query optimization. What order should we be doing with the query? Should we be selecting? Should we be joining? So that kind of analysis will have to be done for the future of the project. And another thing that we wanted to add, as John mentioned, our GUI is rough around the edges, didn't really interact with a ton of graphic design, so we think that we can add a lot more functionality to the GUI, like adding a downloadable table at the bottom for the information that's displayed in the pie chart. Maybe you want to pull that from the website so then you can use that in a presentation, or maybe even just being able to save the state of the website that you're using at the time. So if you log out of it, but then you're like, oh, I really wanted to download that or go back to that, when you go back to the website, it would have the same state that you had just interacted with. These are some of the improvements that we think for the project, and we think that the project has a really bright future. So thank you for coming to talk with us today, and thank you for all of your work with us this semester. Our whole team thanks you, and if you have any questions, this is the time to ask.